In this video, we're going to continue discussing the orbits. So in the previous video, we already talked about all of the electrons are going to be located in something called orbits. Okay, now, but it's not directly. You have to understand that there are certain main energy levels, and under each main energy level you can have sublevels, and under each sublevel you may have one or more orbits, and in each orbits you may find one or two electrons, but no more than two electrons. Different sublevels contain different number of orbitals. For instance, S, P, D, F, in order of increasing energy, also in the order of increasing number of orbitals. And S sublevel has 1 orbital, P sublevel has 3 orbitals, D has 5, F has 7. And because of maximum capacity of 2 electrons in each orbital, so S sublevel would contain up to 2 electrons, P sublevel contain up to 6 electrons, and the 5 orbitals in D would contain up to 10 electrons, and 7 orbitals in F would contain up to 14 electrons. And also using this map, you can see under each principal energy level, you may have one or more than one different sublevels. Now, with this basic information in mind, okay, let's take a look at what is really orbitals. Okay, how do they make up sublevels, and then how this is how each sublevel make up one main level. First of all, we have to understand what is orbital. Okay, let's say this is an s orbital. This is what it looks like. And sometimes people call orbitals also electron cloud, but don't get me wrong, okay? There's only maximum 2 electrons in this region, okay? The orbital certainly does not, indicate the movement of electrons. It only shows you about 90 or more than 90% of chance you'll find the electron in this region. What that means is, let's clarify this orbital shape, okay, which look like this. The color doesn't really matter, okay? The shape does, though. This is a typical s orbital, okay? But without specifying number, this could be 1s on the first principal level, or 2s or 3s. Doesn't matter. They all have the same shape, okay? Except the higher number goes, the size of the sphere ball is gonna get bigger and bigger. Now, this is a 3-dimensional object. What it means is you may find the electron within this range. But of course, you have to imagine that the nucleus is in the very center of this orbital. Okay, so if you point anywhere outside this region, here, or here, or here, you will tell people that most likely you wouldn't find the electron anywhere here, or here, or here. But would you be able to tell people exactly where in this balloon the electron will be located at, specific location? Neither. Okay, the only thing you can tell people is if nucleus is here, then this is the region in the space where you more than 90% of chance you'll find the electron within this balloon. That's what orbital means. Within this range, within the shape, the size, you'll find the electron in the side balloon. Now this is S. Okay, we already said that different orbitals has different shapes. Okay, at different sublevel. Let's take a look at another picture summarizing the first principal level and the second principal level. So we arrange the first principal level at the bottom, second principal level on top, to indicating that energy actually goes up. We already said that. The number here, level 1, level 2, 3, 4, indicating the main energy levels. Okay, the higher it goes, the higher energy goes. Now we already seen this. Under 1s first principal level, there's only one sublevel, which is 1s. Okay, don't forget all these basic numbers. Okay, there's only 1s, and in 1s there's only one orbital, one sublevel, one orbital. Okay, so that's how it's being illustrated here. There's only one sublevel, 1s, and there's only one orbital. This is one. When I say orbital, I mean one of the balloon here. Okay, Now if you go to second principal level, let's go back to the second principal level, you see you have two sublevels, okay, 2s and 2p. Now 2s has only one orbital, but 2p has three orbitals. So there's one orbital in 2s, three orbitals in 2p. There are total 4 orbitals here. So if we go back to the slides, you can see here on the second principal level, which includes all these 4 balloons. Okay, now the purple balloon, sphere balloon here, is the 2s sublevel, which is there's only one orbital. Under this 2p sublevel, there are 3 dumbbell shaped orbitals. I mean, the color doesn't really matter, but the shape you can see 2s and 1s has the same shape, except 2s is a little bit bigger, which you already said that, okay, it has bigger sides, it has a higher energy than 1s. Now you can see 2p sublevel contains 3 orbitals. Okay, since there are 2 p's, okay, so they would have the same shape. Okay, there are 2 p's, same shape, same energy. The difference is because this two dumbbell-shaped orbital, this one dumbbell-shaped orbital laying on one axis, because we're talking about 3-dimensional world here in the space. If you have this much probability you would find the electron within this region on y-axis, then the probability will be multiplied by 3 because of 3-dimensional. You would have the exact same probability on the x-axis as well as the z-axis. So that's the reason you would have 3 p orbitals. Whereas in the case of s orbital, there's no such thing, because this is a perfect symmetrical from all directions sphere ball shape. So there's no specific orientation of this ball. So there's only one probability or one kind of probability. Whereas if you have this kind of linear shape, okay, you would have 3 times of the probability. That's the reason you have 3 balloons here, or 3 orbitals on the 2p sublevel. You can see the labeling here, okay, 1s, 2s with no orientation specification, or you can have 2py, 2px, and 2pz, not only indicating the shape, the type, and the energy level, also indicating the orientation of the orbitals. Now keep in mind, okay, each one of this, on this slide, you're looking at a 1 orbital on the 1s, and 1, 2, 3, 4 orbitals on the second principal level, okay, which has been split into 2 sublevels, 2s, 1 orbital, 2p, 3 orbitals. Now each one of these orbitals, there are 5 total on this slides, contains up to 2 electrons. So you can have no electrons, or 1 electron, or 2 electrons here. You can have up to 2 electrons, up to 2 electrons, up to 2 electrons, up to 2 electrons. There's no 2D, okay, keep in mind, there's no 2D. Starting from the third principal level, you would start having 3s, 3p, and 3d. Keep in mind, d now has 1, 3, 5 orbitals, which has even more complicated shapes than the s and p orbitals. Okay, but again, d sublevel, which starts from 3D, would have 5 orbitals, and each contains up to 2 electrons. Okay, now being said all of these, okay, let's go back to what we have discussed so far. Now when you look at this map, okay, I would call it map, you're looking at each row is one principal level, and each principal level has been split into one or multiple sublevels, and within each sublevel, now you should be able to have the image in your mind. S is kind of sphere shape, and P is the dumbbell shape, and there are 3 of them. Okay, D and F, I'm not requiring any shapes or recognizing the size of shapes, but I'm asking you to memorize there are 5 Ds in each and 7 Fs in each. Okay, and each orbital contains up to 2 electrons. Okay,